Hello, my name is Adam Keller, and I'm a developer advocate on the container service team here at AWS. Today, we're going to dive into ECS Cluster Autoscaling with ECS capacity providers. So let's get right into it. On the agenda, we're going to start with a high-level overview of Amazon ECS, what it is, and just do a very high-level generic overview. And then we're going to dive into the different ways that you can deploy containers onto ECS. That'll be followed by scaling considerations in a containerized world. And we'll talk about the different dynamics of where you need to scale, how you need to scale, and all the considerations when running containers through an orchestrator like ECS. And then, of course, we're going to talk about capacity providers. We'll go through some examples, and we'll talk about cluster autoscaling and where it fits into capacity providers. And lastly, arguably the most fun part is I'll do a live demo where hopefully everything's going to go amazing and it's going to be awesome. So let's get into it. So this is a 300 level talk. So there is some expectation that those watching have some understanding of ECS, of containers and orchestrators in general, but I still want to talk a little bit about ECS and just do a high level overview. So when we talk about Amazon Elastic Container Service, it's a highly scalable, fast container management service, and it makes it easy for developers, operators to run and manage Docker containers. And when we talk about containers, they're ran on what's called a cluster. And when we think of a cluster in ECS, I like to just say it's a logical namespace where you can isolate and run your tasks or containers separately from other environments. And there's, going down the cluster talk a little further, there's no management of the cluster per se. So when I'm operating on ECS, I don't have to think about things like patching or upgrading my cluster control plane. This is all fully managed and abstracted away from me as the user of ECS. And I just focus on deploying my applications, deploying my containers onto ECS. So now that we kind of have a high level understanding of ECS, we've talked through it, let's talk about the ways that you can run containers on ECS. And oftentimes you'll hear these referred to as launch types. So there's two ways that you can launch containers on ECS. One of those ways is using Fargate, AWS Fargate, and the other way is using EC2, which is self-managing your own EC2 instances that you schedule your containers onto. When we talk Fargate, if I'm deploying a service to an ECS cluster using Fargate, I focus on deploying my task or my service, and that's whether I'm an operator or a developer. I don't have to think about managing the underlying EC2 host. I don't have to think about patching, scaling of that host. I simply focus on my task, my containers, and I just want to get them run. And with that comes the only facet of scaling, which is scaling my application and not thinking about everything else underneath. With EC2, however, the focus shifts a little bit because we have to think about managing EC2 cluster capacity. Okay, so we have to think about managing EC2 instances in our cluster, which means we have to provision them. We have to make sure we have enough resources to serve our containers. And then, of course, we have to make sure we're patching and keeping on top of securing those EC2 instances as well. So I really focus on managing resources in two places when I'm using EC2 with ECS, because I'm thinking about my application, my containers, my tasks, and I'm also thinking about the EC2 infrastructure. So for the context of today and today's tech talk, we're going to talk about without Fargate. So we're looking at deploying ECS services onto an ECS cluster that are EC2 backed and not Fargate. Okay, so let's shift to talking about scaling considerations in a containerized world. So as operators, as developers, scaling of the application is critical, right? We have to be laser focused on ensuring that our application can meet the demands of our application's customer. So if it's a web application, we have to make sure that that web application can scale out as demand increases. And then once demand has decreased and our traffic patterns have gone down, we should be able to scale in as well. So there's two areas that we have to think about scaling, because when I scale my containers out, I also have to think about scaling the EC2 infrastructure out, ensuring that those tasks of the tasks which are my containers essentially, to ensure that they have enough resources to be deployed onto. So what does that look like in a mixed cluster? So with ECS, if you're not familiar, there's the concept of a mixed cluster, meaning you can run Fargate tasks as well as EC2 back tasks in the same cluster. So if I'm using Fargate, as I've mentioned before, I really only have to think about scale in one place, and that's the application. That's my service that I'm running. So again, in the example I used before, I have a web service. My focus is thinking about, as my traffic increases, scaling my service out and in to meet the demand. That's it. Because Fargate is essentially a serverless offering, and when we say serverless, that means that you as the user aren't operating or managing the underlying EC2 infrastructure. You're just saying, here's my container definition, get it deployed. Now, when we talk EC2, I need to scale the application as the need arises, just like I do with Fargate. However, I also have to scale out the backend EC2 infrastructure to ensure that as the demand increases and our tasks are getting scheduled, that there's enough resources in EC2 to schedule those tasks onto. When I say tasks, a task is a container or a collection of containers in a task definition. So, when we look at this this cluster, footprint here, the easy way would be to simply have a lot of EC2 instances that are running, and essentially I just have excess capacity. So as my service scales out, I'll have capacity there ready to go. But from a cost perspective, I'm basically paying for resources that are idle and not being used and wasting money. And frankly, as a better practice, as a good practice in the cloud, you want to think about using resources only when you need them and not just keeping them on all the time and spending money for no reason. So rather than having to have those, that idle capacity instances just sitting around, we can think about auto scaling. Now, if I were to do this on my own, there's a lot of considerations. I have to think about the reservation of the different resources required by my tasks. I have to come up with a complex algorithm to figure out how to scale my instances in and out. Or we can use capacity providers. And capacity providers with cluster autoscaling can help solve this problem for us. So what this does is you'll see the kind of the shift in mindset of being infrastructure first, where I have to think about the infrastructure and kind of make sure that I have that solved prior to thinking about my application. I can now shift to application first and think of what does my service need to deploy successfully and to make sure that my service is running and healthy, and less of how much infrastructure do I need to make sure my service can run. When we talk about application first, there's a couple tenets that we follow. And one is that applications own their own requirements. And as I said earlier, as an application owner, my focus should be on ensuring that I have all the tools I need to scale, to run my service, my application, and not have to think about infrastructure first. And with that, the infrastructure should respond to my application requirements. So the shift really changes to how do I, help solve problems for my business, for my customers, and less of how do I solve problems of infrastructure management, and how do I think of infrastructure first and then application. No, you think of applications first because the applications own their requirements and the infrastructure will respond to them. And that leads us into capacity providers. So we've covered, ECS clusters. We've talked about the ways you can launch containers on ECS. We even talked a little bit about the service and the cluster auto-scaling considerations. But let's talk about the capacity providers. We'll talk about strategies. And what we'll look at is how do these fit into everything we've discussed so far? And how do they fit into an ECS cluster and an ECS setup? So a capacity provider is used in association with a cluster to determine the infrastructure that a task runs on. So when we talk about Fargate or Fargate Spot, these are for our Fargate users. Now, these are capacity providers that are basically what we call reserved, meaning they're already available to you for you to use. So out of the box, Fargate and Fargate Spot can be used as your capacity providers to deploy your Fargate services. And for our ECS on Amazon EC2 users, a capacity provider essentially consists of a couple different things. A name, which is defining what your capacity provider is. It points to an auto-scaling group. We'll talk about that auto-scaling group in just a moment, but because that's going to be critical in the cluster auto-scaling piece. And then the settings for your managed scaling and managed termination protection as well. We're going to walk through actually creating capacity providers in the demo. So we'll actually see what that looks like when we create them in the console and what some of our different checkboxes and tweaks are that we can make. So now I want to go over some examples of capacity providers. But first, let's start with just looking at what it takes to get a capacity provider set up. So I have my ECS cluster. Okay, I have an auto-scaling group for my EC2 instances that is set to schedule my C5 instances in the C5 family. And what you'll see is within the cluster is where my capacity provider is. And my capacity provider is what points to an auto-scaling group. So this is a new resource type in ECS. It's been out for a few months now. And what it does is it abstracts the capacity from the operators. So by creating the capacity provider, pointing it to the auto-scaling group, I don't have to think about scaling anymore because the capacity provider will manage that on my behalf. You can have anywhere between 0 and 10 capacity providers per cluster. And ultimately, the capacity providers are used by the tasks or services. So we'll actually look through in the demo, when I modify a service, we'll see the difference between the launch type and then a capacity provider, and we'll go through that when we update a service. Okay, so now what I want to do is I want to talk about probably one of the coolest features with capacity providers and why there's so much value in using this feature for ECS. So, as we go through building these components, I create a cluster. That's a one-time action. And then I have to create an auto-scaling group. That's also a one-time action. And then I create my capacity provider, which points to that auto-scaling group. This all happens the one time when you create the resources, and that's it for your cluster. Now, once I have my capacity provider set up and it's associated with the cluster pointing to my auto-scaling group, I can have my auto-scaling group set to 0, meaning when you look at an auto-scaling group in AWS, you have the option to control the minimum count, the maximum count of EC2 instances, as well as the desired count. So I could set my minimum count to 0, my desired count to 0, and that's when I create the auto-scaling group. And then what that means is when I'm not running anything, I'm not running any tasks on top of that capacity provider, that means I'm not paying for any EC2 instances during that time. Now, once I schedule the tasks, so I run my tasks, the capacity provider is ultimately going to recognize that there's no EC2 instances to support these tasks. So we have, a reservation requirement of, in this example, 6 tasks that requires N amount of CPU and X amount of memory. We're going to scale the auto-scaling group from 0 to the amount of EC2 instances that we need to run those tasks, and ultimately those tasks will get placed onto those instances. So basically all of that we just saw in that talk and in those graphics was the capacity provider managing the scaling for me of the EC2 instances. I simply ran tasks. I said, I want to run 6 tasks, and the capacity provider recognizes there's not enough resources for those tasks to run on. So it schedules more EC2 instances in the cluster. And then as soon as those come up, the ECS tasks get scheduled on those instances. So frankly, I mean, that's pretty cool, right? We were able to scale from 0 to 3. And then once those tasks stop running, the capacity provider would ultimately scale the EC2 instances back to 0 because there's no more requirements for them. And that is really taking advantage of cloud native, thinking about deploying and only when you need, and using resources only when you need them. So you only pay for them when you need them. So now we're going to talk about a couple different ways of deploying capacity providers, and we'll look at strategies. And one thing that I think is important to talk about is with the capacity provider strategy is, what is a strategy? So the strategy determines how tasks are spread across the cluster's capacity providers. So if you look at this example, I have an ECS cluster. I have 2 capacity providers in that cluster. And then if we look to my left, I have a strategy that says, for my first capacity provider, I want a base of 3 and a weight of 1. And then for my second capacity provider, I have a weight of 1 and a base of 0. What this means is, when I deploy my tasks, I need to make sure that out of however many tasks I'm deploying, the first 3 will be scheduled onto capacity provider 1, which means it's going to be deployed. Those tasks will be scheduled onto the EC2 instances from the first capacity provider. Then after that, we follow the weights. So you can see the weight for 1 and 2 is 1. So that means that for every 1 deployed to capacity provider 1, another one, the next one, has to be deployed on capacity provider 2, and it goes back and forth. So the idea is you always maintain your base, and then you follow the weights to determine how to spread your tasks amongst the capacity providers. So what you can see is we have 5 total tasks. 4 of them have been scheduled onto capacity provider 1, and 1 was scheduled onto capacity provider 2. And the way that worked is we met our base of 3 for 1, and then the next task we spun up was scheduled onto 1, and then the following was scheduled onto capacity provider 2, because it was split across the weights between the 2 providers. So if we were to go down this path even further, we take our same cluster, our same setup of our 2 capacity providers, but now what we want to do is add more tasks to the mix. So now I have 2 more tasks that I've scheduled. And so what'll happen is, again, following the weights, we'll see 1 task will get scheduled onto capacity provider 1, and then the next, because it's a weight of 1, and then the next task will get scheduled onto capacity provider 2 because it's a weight of 1. And if I wanted to mix this up a little bit, I could always have, if let's say capacity provider 2, I wanted to use spot instances, I could always up the weight on capacity provider 2 or capacity provider 1 to say, I want to make sure that I always have my base of 3 tasks that are running on on-demand instances in capacity provider 1. But with capacity provider 2, I want to launch more. So I want a heavier weight. So I want, for every 1 that's deployed to capacity provider 1, I want the next 5 to be deployed to capacity provider 2, so we can take advantage of more power, but paying for less because it's deployed on spot instances. So of course, with that, when you talk about spot, there's some potential volatility that comes into play, so that has to be considered. But there are of course ways to work with that, and as long as your tasks, your services can handle that, which generally speaking, when you're talking running containers, generally the idea is they're immutable. They should be able to go away and then come back and pick up where they left off. So this was just another example. The last example we're going to go through is spreading capacity providers across availability zones. So in our cluster, we could have 3 availability zones, and each availability zone is pointed to its own capacity provider. I could have a AZ balance strategy of 0 base, but weight 1 for everything, which means I don't have a base requirement, but I want to ensure that every task that's scheduled, the next task is in a different availability zone, and so on. And so ultimately, what this does is this gives you the ability to spread your tasks across availability zones by using capacity providers. And you don't have to scale in and out, as the capacity provider will manage that scale in and out for you. Okay, so I've done a lot of PowerPoint, a lot of slides. This is cool, but I think that the more fun is actually getting into the console and actually doing this live and doing a demo. So what I'd like to do is jump into my demo next. And what we'll do is, well, we already have an ECS cluster. I'm going to demo setting up capacity providers, and we have a live application that will scale out. We'll have 0 infrastructure, and what we'll see is the capacity providers will trigger the auto-scaling events on our behalf, and we'll see that we'll have the infrastructure needed to meet the demand of our application. Okay, so what we're looking at right now, we're in the AWS console, and I have our cluster open. My cluster is called Container Demo, and I have one service that's deployed to that cluster. Now this service, as you can see, launch type is an EC2 launch type. But what we'll look at here is under the capacity providers, we'll see I don't have any capacity providers set up yet. So what I'd like to do is I'm actually going to create 3 capacity providers in 3 different availability zones, and that point to auto scaling groups in 3 different availability zones. And then we're going to deploy our service. So right now our service is at 0. And our auto scaling groups are set to 0, which actually, let me show you that before we get into it. So if I go to the EC2 in the console, and then we're going to go down to auto scaling groups, what we'll see here is I have 3 auto scaling groups with 0 instances in them. And you can see they're each in an availability zone on their own. So when I drill down into one, you can see my desired capacity 0, minimum capacity is 0, and my maximum is 10. So we're going to go create, we're now going to create a capacity provider that's going to point to these auto scaling groups. So let's do that now. So in the console, I go to capacity providers under my cluster. I'm going to click create. And now we're going to walk through the different options that are available to me as I create this. So one is the capacity provider name. So I'm just going to call this US West 2A demo. And now I pick my auto scaling group. So I'm going to go to the one in US West 2A. And now here's where I can set manage scaling. So you can enable a capacity provider to split across multiple, to point to auto scaling groups that doesn't have managed scaling enabled. But I would assume that if you're doing that, you generally have your own very robust auto scaling logic built on your own that you're using to manage. But if you want to enable cluster auto scaling, you have to just ensure you check enabled under managed scaling. Next is the option for target capacity. So let's talk about this for a minute. When we think target capacity, I mentioned earlier, ideally, you want to be running at, if you're not using resources, you want to just only use what you need, and you don't want to pay for resources you're not using. So if you set a target capacity to 100, this is saying that when you have managed scaling enabled, target capacity is going to try to meet 100% utilization in your capacity provider with your EC2 instances. So that means I don't have any overhead excess infrastructure EC2 instances sitting around. Now, that's not always going to be the case. Sometimes you're going to want a little bit of overhead because you just have an application that needs to rapidly scale, and you just maybe want to have a little overhead just to solve some of the quick scaling needs. And then as auto scaling triggers, that will then manage the rest of the load and be able to serve that traffic. So I could very easily set this to 80%, which means that I always want 20% overhead in my cluster. So if I were to set it to 80% and click create, what you would see happen is my auto scaling group would actually spin up 2 EC2 instances, because cluster auto scaling recognized that we want that 20% overhead. We always want to make sure that we have 80% of utilized capacity, but with that 20% overhead. But for the sake of the demo, we're going 100%, and because I only want to pay for what I use when I use it. I don't need excess capacity in this example. The last thing I want to point out is managed termination protection. This is important because as you scale in, so we talk a lot about scale out, and I try to be cognizant of talking about scale in as well, because to me, it's equally as important. So as I'm scaling out, the one thing that I want to think about is, do I have enough resources to place my tasks? But as I scale in, I may not want to just randomly, terminate instances that are running containers that are actively running something. Maybe they're running through a process, and I want to more gracefully shut those down. So with managed termination protection, ultimately you can use this to ensure that when your cluster scales in, so when we talk about scaling our EC2 instances, we talk a lot about scaling out when we talk about scaling our services. But when we scale in, we have to do it in a more conventional way. We want to be a little more careful. We don't want to just scale in rapidly. So with managed termination protection, this ensures that when a scale in event occurs, it won't terminate an EC2 instance that's running active containers. What it will do is it will target EC2 instances that are not running active containers. Now, the only exception to that rule is if you're running a daemon service, which a daemon service is essentially a mapping of one task to one EC2 host for every EC2 host that comes up in your cluster. So that's the one exception. Okay, so we have our capacity provider. Let's hit create. Done. Very good. So if we go back to the cluster, we can see now I have my US West 2A demo capacity provider. I'm going to go ahead and I'm just going to create 2 more, and I'm going to point them to their proper auto scaling groups. Okay, and then so if we go back, we can see, oops, I just named it 2B, that's fine. And then we'll create 1 more, which we'll name it US West 2C. And I'm going to point this to the auto scaling group in US West 2C. Managed scaling, target capacity of 100% with managed termination protection. One thing to note, when you enable managed termination protection, you also have to enable that in your auto scaling group as well. Okay, we have our capacity providers deployed. We have managed scaling enabled and managed instance termination enabled on those capacity providers as well. Taking a look here in the console, you can see I currently have 0 instances in all of my capacity providers. But I have a service here that has 0 tasks desired. So what we're going to do is we're going to update this service. And we're going to switch to capacity providers, and we're going to split it amongst 3 capacity providers. Okay, so I'm going to start with basically, I'm just going to say I want to do a base of 0 for all, and we're going to do a weight of 1 across all 3 capacity providers. So I'm going to skip to review, and I'm gonna update the service. Oops, okay. I updated the service, that's cool. But now what I need to do that I forgot is I actually wanna increase the service count. So I want to run 10 tasks, okay? So I'm taking the service and now I am essentially going from 0 to 10 containers that I want running in my cluster. So as we talked about, if you think through, what we were talking about is we have deployed 10 tasks. Those 10 tasks at this moment have nothing to be deployed onto because they're EC2. The capacity providers point to EC2 backed tasks, which means we need EC2 up and running to be able to support these tasks and get them going. So what will happen is the orchestrator, ECS, is going to launch 10 tasks. So it's going to schedule these 10 tasks. And what will happen is it's going to go into a provisioning state. Now, if you didn't have capacity providers enabled, and your particular service or task pointing to those capacity providers, there would be no capacity available, the task would fail. But in this case, the task is in a provisioning state until the cluster autoscaler can spin up infrastructure, spin up the EC2 instances to ensure that we can then get these tasks scheduled onto them. So this is going to take a minute or two. And what I'd like to do is just go to, and you can already see we're updating capacity for US West 2C here. And I'm sure the other two will be updating soon. What I want to show you is the actual alarm that goes off. So this is our capacity provider reservation alarm. And essentially, this is the capacity provider is integrated with CloudWatch. And what it does is it creates this, through the auto scaling and everything that's being built behind the scenes, it creates this capacity provider reservation metric. And as soon as that metric, so it's basically for, are we at 100% utilization in our cluster, okay, for every minute. So every data point with every minute. And what we'll see is already this one has gone into an alarm state. And now we have a second one that's gone into an alarm state. What that means is that's going to start triggering auto-scaling events in our cluster. So we can go back to our auto-scaling groups. We can see we're now spread. We have 2 instances in 2C, 2 instances in 2A, and we can see capacity is going to be deployed in 2A as well. So now we go back to our cluster. If I refresh my EC2 instances, you can see I already have some that are scheduled. I go back to my tasks. I can see I have 3 tasks that are up and running. I still have more in a provisioning state because the infrastructure is still coming up. The EC2 instances are registering in the cluster. And what we'll see happen is these will slowly but surely start to schedule. And I say slowly, but this has all happened within a matter of a minute, minute and a half. So it's actually relatively quick compared to doing this on your own or doing this manually. So we've gone from, in the last 2 minutes, we've scaled up our service to run 10 tasks. We had no EC2 instances running. Our capacity providers recognized that there was a need to schedule these 10 tasks, but there was no infrastructure to meet that demand. So it scaled out, and now our tasks have been scheduled. And this all happened within a matter of a couple minutes. So now you can see we are fully up and running with our 10 tasks, and the cluster autoscaler did its job. So we have 6 EC2 instances running. All of our tasks are running. Our containers are running. And let's actually, just for fun, if we go to my service, it's a load balance service. It's a very simple, just API. And all it does is, let's go to it there, is it just gives me a response of what capacity provider am I using? And what capacity providers are all the tasks using in my cluster? So if you take a look here, I keep refreshing, I can see I landed on a task that's running in US West 2A using the US West 2A demo capacity provider strategy. I keep refreshing, and now I hit a 2B. So if you remember, when we deployed this, we wanted split across the 3 capacity providers. So if I count 1, 2, 3, 4, and then 2, 1, 2, 3, 4. Anyways, my math's not good, but you can see we have 3, 3, and 4, which equals 10. So my math's better. But the idea is we split 1 across each of each capacity provider as they're deployed, and you can see we did 10. So we've met our minimum of 1 across each one, with 3 in each, and then the next one, which was, I believe, was it 2B, that has 4. So as you can see, that was pretty straightforward, and honestly, like, to set that up was not very difficult. So the whole idea here is you don't want to think about managing scaling in all these different places. You really just want to think about your application, and you want to focus less on the heavy lifting of managing, the virtual machines and everything in your cluster, and more on deploying your services, getting your tasks out there, ensuring your application can do what it needs to do and scale to meet the demand of your application's customers. So let's go back to the slides. So to get started, check out our documentation on aws.amazon.com/ECS. Specifically, you can get more documentation around capacity providers just by following these links. And also, I want to give a shout out to ECSworkshop.com. So if you want to get hands-on with capacity providers and deploy that demo app that I just deployed in my demo, go through ECSworkshop.com/capacity providers. You can actually we deploy two ways using capacity providers. One, we showcase cluster autoscaling, and 2, we actually showcase deploying a Fargate service that's split across Fargate and Fargate Spot. So we get to take advantage of that Spot cost savings, but mix it with on-demand Fargate. So that's it. I want to thank everybody for joining us today. If you have any questions, please feel free to ask, and we're glad to answer them. Thanks so much, and please follow me on Twitter at @RealAdamJKeller. Thank you.